Problem 5.3.5. You are asked to use Thevenin circuit to find I sub 0 here. So for the Thevenin, we need to find VTH and RTH. To find the RTH, we need to let independent voltage source for short circuit, independent current source for open circuit. So we can let this 20 independent voltage source to short circuit here. However, we have a problem in here because this is dependent voltage source. In this case, we need to do Norton circuit first, and we need to take this 2 kilo ohm out for the RTH. But for the Norton, we need to make it short circuit and we need to find I sub n. Since VTH RH Thevenin is the same as the Norton, so once you find the I sub n, then we can use I sub n to find RTH. How? We need to find VTH over IN. So once you find the VTH and IN, we should be able to find RTH. So now what? How we find the I sub n? We can identify the node in here. That's the ground node. And if we do KVL in here, then we have a negative 20 plus Vx equals to 0. Therefore, Vx equals to 20. That makes sense. It's a simple one loop circuit. We have one voltage source and one resistor. So that has to be 20. If this Vx is 20, then current going through this Ix is going to be V over R. Vx over 2K, 20 over 2K, which is 10 milliamp. And now we can do KCL at node. So KCL at node A. Now we have Ix entering, IN leaving, and it's really up to us. You set the direction of the current either way. So I'm gonna go this way, and then we know this is 2Vx. So I sub x entering equals leaving I sub n plus leaving V A minus 2Vx over 4K. What is VA? VA equals to 0 because that's ground connected. And then we have Vx as a 20. So if we rewrite this, it's going to be I sub x equals I sub n plus negative 2 times Vx is 20 over 4K. Ix equals In minus 40 over 4K. That's the 10 milliamp. And we found the Ix 10 milliamp, and if we move this guy to over, plus 10 milliamp equals to I sub n. So I sub n equals to 20 milliamp. So now we need to find the VTH. They are not the same because there's a short circuit line in the previous one. Now we have an open portion in there. Whatever we found as a Vx in the previous case is not going to be the same in the second case. To find the VTH for this, we can do is open circuit. So KVL negative 20 plus 2K I sub 1. We're going to call it I sub 1 plus 4K I sub 1 plus 2Vx equals to 0. Now we know the Vx equals 2K I sub 1. So we're going to substitute it in here. Then 2K I sub 1 plus 4K I sub 1 plus 2 times 2K I sub 1 equals 20. 10K I sub 1 equals to 20. From here, I sub 1 equals 2 milliamp. Okay, so if we use this I sub 1 here, then we have Vx in this case. Vx gonna be 4 volt. And now we do KVL in a small loop. Then we have negative 20 plus 4 plus VTH equals to 0. From here, VTH equals 16 volts. So we have IN as a 20 milliamp and VTH as a 16. Now we can find RTH equals to VTH over IN. VTH over 20 milliamp. That is 4 over 5 kilo. You can have Thevenin circuit. That is VTH equals 16. Series RTH equals 4 over 5K. And then Norton circuit gonna be IN equals 20 milliamp parallel to RTH. That is 4 over 5 kilo. That's it. Now, the missing term we took out from the original problem, that was 2K, and then I sub 0 is going down. This is 2K, and I sub 0 going down. Using Thevenin, we can find I sub 0 as V over R, right? So V 16 over R 4 over 5 plus 2K. That is 10 over 14 over 5 milliamp, because K is at denominator, so we're gonna bring it up. It's gonna be milli. 16 over 1 times 5 over 14, 40 over 7 milliamp. If we use Norton, then I sub 0 is gonna be, we can do the current division. The opposite 4 over 5K and sum, and then total, that is 4 over 5 for the numerator, denominator 14 over 5 times 20, that is 4 over 5 times 5 over 14 times 20, 40 over 7